Hey guys, in this video the lovely Mr. B is going to be working you through simultaneous equations for your AS and your A-level maths. So getting some quite tricky examples in here. They're going to be at 3 different levels, and if you use the pinned comment down below you can jump between those levels however you want to. If you start at the medium ones and find them too easy, then you can move to the harder ones, or if you find them too hard you can move to the easy ones. Use this video in the way that you see best. No one is watching you, no one is judging you. If you want more practice questions to help you really work on this skill, then there are thousands waiting for you over my website.
With simultaneous equations, we can't use our normal equation solving methods because we have 2 variables. So our first job is to get rid of a variable. One trick is when you write these, write the largest numbers on top. So I'm actually going to flip around the order of the 2 equations we've been given. Now the easiest way to eliminate a variable is to take the 2 equations away from each other. And when you do this, you take each term away one at a time. So then do x terms first. 5x, take away 5x is 0. So there's nothing to write down. Then the y terms, 8y, take away 7y is 1y. And then the numbers, 102, take away 93 is 9. So straight away, y is equal to 9. For our next step, we want to find out what x is equal to. So we take one of our original equations. Let's start with the top one. 5x plus 7y is equal to 93. Now, as we know that y is equal to 9, we know that 7 lots of y will be 7 lots of 9, which is 63. Now we have an equation with one variable that we can solve. We can take 63 from both sides, leave us with 5x is equal to 30, and then divide both sides by 5, giving us x equals 6. At the end, I strongly suggest you write out your answer nice and clearly, because these answers can get lost in the working out. So we want to write that x is equal to 6 and y is equal to 9. Moving on to our next example, now you'll see here that if we take these 2 equations away from each other, like we did with the last example, what's going to happen is we get 8x take away 6x is 2x, 3y take away 1y is 2y, and 55 take away 35 is 20. And so what's happened is we haven't eliminated one of the variables, and so this hasn't really helped us too much. So how can we eliminate the variable in a case like this where the numbers don't line up? Because in the previous example, the one where we eliminated had the same number for both. So what we're going to do is choose a number. Now, for this one, the easiest one is y. We're going to keep the top equation the same. 8x plus 3y is equal to 55. But for the bottom one, we're going to multiply it by 3. And what that does for us is it gives us 18x plus 3y equals 105. So just multiply all 3 terms by 3. And by doing that, now the y values line up. So now we can do our takeaway. Now, before you take away, again, just think about which way around you want to take away, because you have to be consistent. You can't just take away whatever's easiest. So you can't do 18x take away 8x to get 10x, then later on do 55 take away 105. It's got to be top take away bottom or bottom take away top for all 3 terms. So I'm going to write this out again. Let's have 18x plus 3y equals 105 on top, and 8x plus 3y equals 55 on the bottom, to make it so we don't need to deal with negative numbers. 18x take away 8x is 10x. 3y take away 3y is 0 lots of y. That's how we did it. We've eliminated y. And 105 take away 55 is 50. Now, unlike the last question, this hasn't given us x straight away. We have 10x equals 50, but now we have a single variable, so we can solve the equation as normal. We can divide both sides by 10 to get x is equal to 5. Now we know that x is 5, we can now find out what y is. All we need to do is choose one of our original equations. I'm going to choose the 6x plus y equals 35. And I've chosen that just because it's got smaller numbers involved. You could actually choose either of the 2 and they would both give you the same answer. Now we have 6 lots of x. We know that x is 5. So 6 lots of 5 will give us 30 plus y is 35. So y must be equal to 5 to make that equation work. 30 plus 5 is 35. The final thing to do is to write out your answer nice and clear. So we have x is equal to 5 and y is equal to 5. And you should be able to see really clearly the 3 steps. The first step is equalize one of the variables. Either the x's or the y's should have the same coefficient. If they don't, multiply to get there. Then we need to eliminate one of the variables by, in this case, taking away. That will give us one of the other variables. Once we know one of the variables, we then substitute it in to get the other variable. So let's try those 3 steps with the next example. So we can see with the x's, we've got 8x and 1x, they're not equal. And with the y's, we've got 8y and 2y, they aren't equal. So we could multiply the bottom equation by 8 to make the x's be equal, or we could multiply the bottom equation by 4 to make the y's be equal. Now, it would work either way and get the same answers. But what I'm going to do is, I'm going to multiply the bottom equation by 4, just because multiplying by a smaller number should lead to smaller numbers and easier maths. So we keep the top one the same, 8x plus 8y equals 72. But we're going to multiply the bottom one by 4. X times 4 is 4x. 2y times 4 is 8y. So we can see the y's now have the equal coefficient, they're both of 8. And 16 times 4 is 64. So what we want to do now is have a look at what we've got and think, right, can we take this away? Do we need to switch them around? Now we do have the large numbers on top, so we should be good to go with that equation. Now I'm just going to write it out another time, and we're going to do the takeaway. So 8x take away 4x, it's 4x. 8y take away 8y is 0. That's why we did it, to get rid of it. And 72 take away 64 is 8. So now we have the linear equation, 4x equals 8. There's only one variable, so we can solve it. Divide both sides by 4, and we get x is equal to 2. So that's our second step done, and now we know one of the variables. For our third step, we just need to substitute into one of the equations, and we'll choose the bottom equation. Again, it's just got smaller numbers, it'll be a little bit easier. X plus 2y is equal to 16. We know what x is, it's 2. So 2 plus 2y is equal to 16. So we know that 2 plus 14 is 16. So 2y must be 14. That means that 1y must be 7. Now we've done all 3 steps, just write out your final answer nice and clear. X is equal to 2 and y is equal to 7. Don't leave your answers buried in your working out. Make sure they're nice and clear at the end. Now, our next example is a little bit more difficult because we can see the x's and the y's don't have the same coefficient, but then how do we make them be the same? How can we multiply 3x to go up to 7x? How can we multiply 3y to go up to 8y? There's no nice simple multiplication we can do here. So we need to use a different technique. Now what we're going to do is multiply the coefficients by each other. I'm going to choose x because x has got smaller numbers, only just. So I've got 3x and 7x. That means I'm multiplying by 7 and by 3. But you'll notice I've flipped around the order. I'm multiplying 3x by 7 and 7x by 3. And this works much the same as when you add fractions and the denominator is the same. Let's see what happens. 3x times 7 is 21x. 3y times 7 is 21y, and 21 times 7 is going to give us 147. Then we do the bottom row. 7x times 3 is 21. So you can see multiplying those x coefficients by each other has now made the x coefficients be the same. 8y multiplied by 3 is 24y, and then 53 times 3 is going to give us 159. So now we've equalised the coefficients on one of the variables. Now we need to do something to eliminate one of the variables. I'm going to change the order. I'm going to put the bottom one on top because it's got larger numbers. Again, trying to avoid working with negative numbers that can complicate things. So we're going to take them away from each other again. 21x take away 21x will give us 0. That's how we did it. And then next we're going to have negative 24y take away a negative 21. I'm going to be really, really careful with all the negative symbols here. We write it out properly. Again, if we just highlight this, we've got the first number, and we've got the second number, including the negatives, and we have the takeaway symbol in the middle. We can see we have a double negative, so it's going to be negative 24. It's actually going to be plus 21. That gives us negative 3. So it's going to be negative 3y. Then 157 take away 147. That's going to give us 12. So now we have an equation we can solve. We can divide both sides by negative 3. Giving us y is equal to negative 4. So now we've found the value, one of the variables, we can move on to our third step. And then choose the equation with the smaller numbers. So that one would be the 3x minus 3y equals 21. Now again, being careful negative numbers, 3x take away 3 lots of negative 4 is equal to 21. When you substitute, we're going to end up with negative 3 times negative 4. That means that 3x plus 12 is equal to 21. So then we solve the equation, subtract 12 from both sides, 3x is going to be equal to 9, and divide both sides by 3, x is equal to 3. Write out the answers clearly, x equals 3, y is equal to negative 4. Now our last easy example has a little bit of a difference in it. Now, we should be able to see that we can multiply 2y by 4 to get 8y. So multiply the top by 4 to get 8x minus 8y is equal to 48, and then keep the bottom one the same. Negative 7x plus 8y is equal to negative 47. Now you can see the coefficients on the y's are both an 8. The problem is they're both not the same. They're not both a positive 8, and we can take them away to get 0. We have a negative 8 and a positive 8. Now, if we took these away, what would happen is we would have negative 8y take away a positive 8y. And we'd have negative 8 take away another 8 is negative 16. So taking them away isn't going to get rid of the y variable. But what we can do instead is we can add these ones together, because a negative 8y plus an 8y, that will give us 0. So with simultaneous equations, it's not always a takeaway. Sometimes it's an add, but you've got to think really carefully about which one it's going to be. Now, if it's positive numbers, it's going to be a takeaway. If there's negative involved, sometimes it'll be a plus. Just pay close attention to which one it might be. So let's add these together. So 8x plus negative 7x. Now you can write this out, you get a bit confused. 8 plus a negative 7, a plus the minus, 8 take away 7 is 1. So that'll be 1x. Then the negative 8y plus 8y will give us 0. That's why we're doing this. And then for the last part, we're going to have 48 plus negative 47. That should give you 1. So straight away, we know that x is equal to 1. So now we just need to substitute. I'm going to substitute into the top row because that has smaller numbers. So we have 2x, take away 2y is equal to 12. We know that x is 1, so 2 lots of x will be 2. 2 take away 2y is equal to 12. Be really careful how you solve this. Try and do it properly and don't try and guess. So we can take 2 away from both sides. Negative 2y is equal to 10. Then divide both sides by negative 2. That'll give us a y is equal to negative 5. Now we know our final answers. We can write them down nice and clearly. We can write that x is equal to 1 and y is equal to negative 5. Now, one extra thing I want to show you is a way to check your answers. And this is the fourth step. It doesn't give you any extra marks, but it just lets you know that you've got the right answer. Now we substitute it into the top equation. What we're going to do now is substitute into the bottom equation. So let's have a look at that. We'll have negative 7x plus 8y equal to negative 47. Now we know that x is 1, so negative 7x will be negative 7. We know that y is negative 5, so 8 lots of negative 5 will give us negative 40. And so when we substitute into the second equation, we have negative 7 take away 40 is equal to negative 47. And we can see that that is true. Both sides are equal to each other. So by doing substitution into the other equation, it just lets you know you've got the answer correct if they both match up. If we did this and we didn't get negative 47, then we would have known for sure we made a mistake somewhere, and we go back and check. Now, I'm not going to show this method for the other ones in this video, but this is something you should be doing in the exams just to check. For the next question, we've got a squared symbol involved in our simultaneous equation. There's a few different ways of doing this, and we'll go through two. So the first way is let's equalize the x variable, so the one that isn't squared. So we're going to keep the top the same. 4x plus y squared is equal to 5. And we're going to multiply the bottom one by 2. That will give us 4x plus 2y is equal to 6. And then, like we did before, for our second step, we can take these away from each other. So we're going to write this out again. Now, you'll notice I'm not going to swap around the order to make the larger numbers be on top. I'm going to keep the y squared on top for this, and you'll see why in a moment. So let's do the takeaway. So 4x take away 4x will give us 0x. That's why we did this. Y squared take away 2y. Those two things aren't going to cancel out. They're not going to do anything with each other. We have to keep squareds separate from normal letters. So we're going to write y squared, and we're taking away the 2y. Then look at the numbers at the end. We've got 5 take away 6. That will give us negative 1. Now I'm going to rearrange this to be an equation that's equal to 0. So we have y squared take away 2y. And if we add 1 to both sides, we'll get this. And what we have now is a quadratic equation that we can solve. Now, you can solve this using any method you like. I'm not going to spend too long going through how to factorize this. This one, just using InSpectre, I can see straight away, it's going to be y minus 1 on both sides. And if you multiply out those two brackets, we should get back to y squared, take away 2y plus 1. Now, to make it equal 0, if we make the bracket equal 0, y would have to equal 1 to make the first bracket to 0, and y would have to equal 1 to make the second bracket be 0. Those are both the same, so we only have one answer for y. Sometimes you might have two answers, and we'll see that in future questions. Now that we know that y is equal to 1, I'm going to take one of our original equations. Now I'm going to take 2x plus y equals 3, because there doesn't have any squared numbers in it, which will make it harder. So that'll be 2x plus 1 is equal to 3, because we know what y is. And so 2x must be equal to 2, and x being equal to 1 when you solve the equation. So writing out our final answer, x is equal to 1, and y is also equal to 1 for this question. So we have one set of answers, and we did it by equalizing the variable that wasn't squared. The second method I'm going to show is by substitution. So what I'm going to do is I'm going to use the bottom equation as a base. The one with the squared in it is going to be a base equation here. So that is x squared plus 3y equals 19. And what I'm going to do now is I'm going to take the top equation and I'm going to rearrange it to be y equals something. So x plus y is equal to 7. We take x away from both sides, y is equal to 7 take away x. And so what we can do now is substitute that in place of the y. That would give us x squared plus 3 lots of y. And we said that y is equal to 7 take away x. And that's going to be equal to 19. So let's expand the brackets. 3 times 7 is 21. 3 times negative x is negative 3x. So all equal to 19. And let's rearrange it to be in the format we expect from a quadratic. So we'll have the x squared first. Then we'll have the x term, negative 3x. And then let's take 19 away from both sides to make it equal to 0. So 21 take away 19 is 2. Now we have a quadratic, we can solve this. So to factorize this, it's a plus 2, so that must be 2 times 1. We have an x squared, x times x. And what a negative 3x, that'll be take away 2 and take away 1. Once it's factorized, we need to make the brackets equal to 0. So the first bracket, x would have to be 2 to make the first bracket be 0. And the second bracket, x would have to equal 1 to make the second bracket be 0. So we have two answers for x. Now, because we have two answers, we have to substitute in both. So I'm going to choose the top equation, x plus y equals 7 to substitute. It's nice and simple. Now, our first alternative is x being 2. So that'll be 2 plus y is equal to 7, meaning that y must be 5. 2 plus 5 is 7. Our second alternative, x plus y equals 7, was x being 1. That'd be 1 plus y is equal to 7. Well, 1 plus 6 is equal to 7, so y must be 6. So we have two answers for x, and we have two answers for y. The last thing to do here is, it's not clear which x answer goes with which y answer. So we have to write it out clearly at the end. Now, the x equals 2, that produced the y equals 5. So those two are linked together. Then the x equals 1 produced the y equals 6. So those two are linked together as well. So you have to write the right ones next to each other, or you might lose a mark. You don't want the examiner to be assuming which ones to go together and maybe reading and working out incorrectly. So for our next example, I've shown you how to substitute and get your answer. I've shown you how to eliminate and get your answer. Now, which one you use depends on the question. So for example, with this one, with all the negative numbers, I don't particularly want to rearrange it. So I don't think I'll be using substitution. So I think what I'll do here is use elimination. And I can see straight away, all I need to do is multiply the top one by 2 to make the x values be the same. That will give me negative 2x take away 4y is equal to 2 on the top. Keep the bottom the same, negative 2x plus 4y squared is equal to 2. Now, if I took these away from each other, negative 2 take away a negative 2, I get a double negative there. And so it's going to end up being negative 2 plus 2x. So this is a situation where I do have negative numbers, but I'm still going to do a takeaway. Now, in the past, I've been rewriting these and rearranging the order. Now, what I'm going to do is just go straight to it. But what I'm going to do is I'm taking the bottom away from the top. And the reason why I'm doing that is I want to keep the kind of the 4y squared as positive. So I don't want to take away 4y squared. So I'm doing negative 2x take away negative 2x, which is 0. But then I'm doing the positive 4y squared take away the negative 4y, which gives a positive 4y. Then 2 take away 2, which is 0. So again, what you can do here is you can flip around the order of the two equations. That's fine. Just make sure you're consistent. You do the same thing for all three. So for each one, I've got the bottom number and I took the top number away from it. Now I've been left with positive numbers. So straight away, I've got something that can be factorized. So we've got 4y squared plus 4y. Now practically here, we have a plus 0 equals 0. So we don't have that third term. So this isn't going to be a quadratic factorization. What I'm going to have to do here is just do a linear factorization. And with the 4y squared and the 4y, I can take 4y out of both. So I'm going to take 4y out as a factor, 4y squared with that 4y removed, just y left over. And then the 4y with the 4y removed is just going to be 1 left over. Effectively, I'm dividing both by 4y. So 4y divided by 4y is 4y squared divided by 4y is going to be 1y. And this is equal to 0. So when you factorize this, again, we want to make the brackets equal 0. We've only got one bracket, so that one's telling me that y is going to be equal to -1. Now, if the other term doesn't have a plus or minus with it, then it's going to be equal to 0. Because if y is 0, we're going to have 4 times 0 is 0 on the outside. So then no matter what the bracket is, it's going to be multiplied by 0 to give us 0. Now we've got two possibilities for y. We need to substitute in both. I'm going to choose the top equation that's got smaller numbers. -x take away 2y is equal to 1. So our first alternative is y being 0. That would be -x is equal to 1. Now I want this to be positive. So let's multiply through by -1. -1 times -1 is a positive 1, and a positive 1 times -1 is -1. Or if you prefer, we'll just flip the signs on both sides. For our second alternative to -x take away 2y equals 1, is y being -1. Now be very careful with negative numbers here. It's going to be -2 times -1. -2 times -1 is a positive 2. Now again, be careful with how you do this. Let's take away 2 from both sides. -x is equal to -1. We want x to be positive, so we can flip the signs on both sides. X is equal to 1. The last thing to do, be really, really clear with your answers. The x equals -1 came from when y is 0. The x is equal to 1 came from when y was equal to -1. So again, pair them up correctly at the end. Our next example already has the coefficients on y equal to each other, but the opposite signs. So we need to add these two together. So 4x squared plus x, we can't do anything there. 3y plus a -3y gives us 0, that's why we're doing this. And 52 plus 16 gives us 68. And then we rearrange to make this into a quadratic. So we have 4x squared plus x, and we take 68 away from both sides to make it equal to 0. So now we want to factorize. This is a trickier factorization. So rather than doing this by inspection, this might be one where the quadratic formula is going to be helpful for us. So with the quadratic formula, x is going to be equal to -b plus or minus the square root of b squared minus 4ac all over 2a. We have a is 4, b is 1, and c is -68. So doing that substitution, x is going to be equal to -b, which would be -1, plus or minus the square root of, so b squared is 1. We take away 4 lots of a times c. So that's 4 times 4 times -68. This is going to be quite a large number. 4 times 4 times -68 will give us -1088. And that's a double negative, so 1 take away a -1088 is going to give us a positive 1089. And all of that is divided by 2 lots of a, and a is 4, so 2 times 4 is 8. So we need to work out what x is. Let's say the plus minus is positive first. That will give us -1 plus the square root of 1089, all divided by 8. And it actually gives us a positive number. X is 4. Then we're going to take plus or minus be negative. -1, take away the square root of 1089. It was -34 divided by 8. That gives us -4.25 or 4 1/4. So this is definitely one we probably would need a quadratic formula for because we've got a fraction as one of the alternatives. So now we need to substitute both in. So let's use the easiest of the two equations. X take away 3y is equal to 16. Let's take x is 4. So take 4 away from both sides, divide by -3, and we get that y is equal to -4. Now let's do the same thing, but take a second alternative, and that is x being -4 1/4. So we have -4 1/4, take away 3y equals 16. Let's add 4 1/4 to both sides. That's -3y is equal to 20 1/4, and then divide both sides by -3. Now I'm going to use a calculator for this one. So 20.25 divided by -3 is going to give us -6 0.75 or 6 3/4. You can write it as a fraction or a decimal is fine. And as usual, for our final step, write down the final answers nice and clearly. So when x was equal to 4, that gave us y is equal to -4. And when x was equal to -4 1/4, that gave us that y was equal to -6 3/4. Now we'll do the last one by substitution. So we'll take our 4x squared minus 4y equals 8. And we're going to make the next one be y equals to something. So taking the bottom equation, -2x minus 3y equals -2. Let's add 2x to both sides and divide both sides by -3. That gives us y is equal to, so -2 divided by -3 will give us a positive 2/3. And 2x divided by -3 is going to give us a negative 2/3 of x. So let's substitute that in. 4x squared minus 4 lots of our 2/3 minus 2/3 x. That's all equal to 8. So now let's expand the brackets. So our 4x squared, take away 4 times 2 is 8. That'll be 8/3. -4 times a -2 will give us a positive 8. That'll be positive 8/3 x, all equal to 8. And then let's rearrange it. So we have 4x squared. Our x term is 8/3. Now we can actually change that to a mixed number. 8 divided by 3 is 2, remainder 2. So 2 2/3. And then we have our negative 2 2/3, and we take away 8. So it'll be -10 2/3 is equal to 0. Now, this might be one for the quadratic formula, but you probably don't want to put decimal answers into it. So a little trick we can do here is, since our fractions are over 3, we can multiply everything through by 3. 4x squared will become 12x squared times by 3. Now, with the next one, 2 times 3 is 6, but 2/3 times 3, that kind of over 3 will cancel out, leaving us with a 2. So we're going to have the 6 and the 2 all together. That will give us 8x. We can do the same thing with the 10 and 2/3. So the 10 times 3 will give us 30, and the 2/3 times 3 will give us 2. So 2 and 30 is 32. And now we've got something that's a little bit more reasonable to substitute into the quadratic formula. So with the quadratic formula, this is going to be at -b, it's a -8 plus or minus. The square root of b squared, well, 8 squared is 64. And we're taking away 4 times a, which is 12, times b, which is -32. So 4 times 12 times -32 gives us a large negative number, and it is -1536. And so with that double negative, we're going to add those two numbers together, and it's actually going to give us 1600. And while it looks like a large number, remember the square root of 16 is 4. So actually the square root of this is only 40, which is a much more reasonable number. Finally, we divide by 2a in the quadratic formula. A is 12, so 2 lots of 12 is 24. Now, to figure out what x is, let's say that plus or minus is going to be a plus. That gives us -8 plus the 40, and then divide by 24. That gives us 1 1/3. Next, let's say that the plus or minus will be a minus. That's -8, take away 40, and divide that by 24, and that gives us -2. So while some quite large numbers there are confusing fractions, we've actually got some reasonable answers out the other end. Now we need to substitute into our original equation. Let's take the one that doesn't have a squared number in it. So -2x, take away 3y equals -2. So for our first one, let's take the x equals -2, because that's easier. That'll give us -2 times -2, which is going to give us 4. So that would be 4 take away 3y is equals -2. Take 4 away from each side will give us -3y is equal to -2 take away 4 is -6. And divide both sides by -3 will give us y equals 2. Then we do the same thing with the same equation, but this time x is going to be 1 1/3. So -2 lots of 1 1/3, take away 3y is equal to -2. So 1 1/3, that will be equal to, it's probably easy to turn it into a mixed number. 1 1/3 is 4/3. So if we times 4/3 by 2, that will give us 8/3. So we have -8/3, take away 3y equals -2. We're going to add 8/3 to both sides. Might be helpful to change a 2 into thirds. 2 is 6/3. So that will leave us with -3 is equal to -6/3 plus 8/3 will leave us with 2/3. Then we divide both sides by -3. That gives y is equal to -2 ninths. So if you're dividing a fraction, just multiply the denominator. Final thing to do is find some space to write out our final answers. So when x was equal to -2, y was equal to 2. And when x was equal to 1 1/3, y was equal to -2/9. Now you'll notice a lot of work with fractions here as well, but this is what set this kind of simultaneous equations apart from the ones at GCSE. We have a little high level of complexity with some of the basic maths work you have to do within the question. Now we've looked at substitution and elimination as methods to solve simultaneous equations. Now we'll look at a slightly different method. Now this is similar to substitution, it's just making both equations equal to one of the variables. So here you can see they're both equal to y. And this is common with graphs because y equals something is the way that we normally write down the equations of lines. So both of these could be the equations of straight lines. Now, if these were straight lines, the answers to this will be the crossing point of the two lines. So it's quite important to look at things like this. So if we're saying that y is equal to 3x minus 16, and y is also equal to x minus 4, then we can make them equal to each other because they're both equal to y, so they should be equal to each other. So we can solve this equation. We can take x away from both sides, we can add 16 to both sides, and we can divide both sides by 2. And so now we know that x is equal to 6. So now let's substitute. If y is equal to x minus 4, and we know that x is equal to 6, y is equal to 6 take away 4, so that will be equal to 2. Write in your final answer, x is equal to 6 and y is equal to 2. So again, that seems fairly easy, but let's look at what this actually means. So if you look at a graph, I've got y equals x minus 4, which would look something like this. It's just a sketch. And y is equal to 3x minus 16, which would look something like this. Then these two lines have a crossing point, and that crossing point is our answer. It's the coordinate 6, 2. The x coordinate is 6 and the y coordinate is 2. So that's a practical use of this kind of simultaneous equation. And if you prefer to draw the graph, you can actually solve it by drawing the graph. Although you can only do that if you've got the graph provided, but you will be asked to do that sometimes. So the next example, again, we have two lines. We have 3x plus 8, and that's equal to y. And we have 5x plus 16, that's equal to y. So let's solve it. Take 3x away from both sides. Take away 16 from both sides. Divide both sides by 2. So x is equal to -4. Substitute that into one of the equations. If x equals -4, then y will be equal to -12 plus 8, and -12 plus 8 is -4. So for our final answer, we're saying that x is equal to -4 and y is equal to -4. And again, if this was a graph, the coordinate -4, -4 would be the crossing point of those two lines. So you might be asked to plot the two lines, and you'll see -4, -4 being the coordinate where the two lines cross. Let's have a quick look at one more example. So 5x minus 17 is equal to -2x minus 11. So again, the two equations that equals y have been made equal to each other. We can add 2x to both sides, add 17 to both sides, and divide both sides by 7. X is going to be equal to 4. We can substitute that into one of the equations. So x is 4, that'll be y is equal to -8 plus 11. And -8 plus 11 is 3. So for our final answer, saying that x is equal to 4 and y is equal to 3. And again, alternatively to this, if you don't want to do the algebra and you've got the graph ready, you could plot these two lines on a graph, and then the crossing point should be the coordinate for 3. Sometimes exams will force you to use a certain method. So the exam says you have to use the graphical method. You have to plot these two lines and prove you know how to plot line, and then you can solve it by looking at where they cross over. If you do that and you think it's the coordinate 4, 3, one thing you can do is do then the algebra version at the side and see if you get the same answer with the algebra version. And if you do, then you definitely know that you've got the right answer. Where this method can get more difficult is when we have something like this and we have a square root involved. Now we can start off the same way. So 2x minus 2 is equal to the square root of 4x plus 4. The first thing we want to do is get rid of the square root symbol. So what we can do is we can square root both sides. We can square root the left-hand side and we can square root the right-hand side. Well, if we do that, now we're ending up with a squared expression in brackets and we need to multiply that out and we need to do it properly. So that'd be 2x minus 2 twice if it's squared. So multiply the brackets. 2x times 2x would be 4x squared. 2x times negative 2 would be negative 2x. Negative 2 times 2x is negative 4x. Sorry, the previous one should have been 4x as well. So I'm just rushing through this. You should know how to multiply it, double bracket. And negative 2 times negative 2 will be a positive 4. So we end up with this expression. Let's collect it all together. We're going to have 4x squared. Look at the x terms. So 4x take away 4x is negative 8x. Take away the 4x on the other side as well. That'll be negative 12x. Then with the normal numbers, we've got a plus 4. We need to take away a 4 from the other side as well. So that's actually going to give us 0. So our quadratic is going to look like that. So given that we only have 2 terms and the missing one's a number term, this will be a linear factorization. Now we can divide both of these terms by 4, and we can divide them both by x. 4x squared divided by 4x is x, and 12x divided by 4x is going to be 3. So from the bracket, x is going to be equal to 3 to make the bracket equal to 0. And from the outside term, x has to be 0 to make the outside term be 0. So now we have our 2 alternatives for x. Now it should be a fairly simple substitution because y is only equal to 2x minus 2. So if x is 0, y is equal to negative 2. And the other alternative, if x is 3, y is going to be equal to 2 times 3 is 6, take away 2, which is 4. So while the rearrangement of the quadratic bit may have took a little bit longer, the substitution at the end was a little bit easier. Write any final answers. When x was equal to 0, that's when we got y is equal to negative 2. And when x was equal to 3, that's when we got y is equal to 4. For our last question, again, we have got 2 lines. We've got a curved line, 2x squared minus 5, a linear line, negative x minus 4. They're both equal to y, so we can make them equal to each other. Rearrange it to be a quadratic. 2x squared, add x to both sides, and then add 4 to both sides. And this is the quadratic we're going to end up with. We can factorize it. Now to get a 1, it'll be 1 times 1. To get 2x squared, it'll be 2x times x. And we want to get a positive x, so that's going to have to be plus 2. Now it looks like a 1, it's going to be multiplied by the 2x, and then take away 1. Going to make the brackets equal to 0. So x would have to be negative 1 for the second bracket. And for the first bracket, 2x would have to be equal to 1. So 1x would have to be equal to a half. So we can substitute in. If y is equal to negative x, take away 4. Then if x is negative 1, y is going to be equal to negative 1, take away 4. That will give us negative 3. With our second substitution, if y is equal to negative x, take away 4. Our other option was x being a half. So y is equal to negative half, take away 4. And negative half, take away 4 is negative 4.5. Write down your final answer at the end. So when x was negative 1, we got y was equal to 3, or negative 3 rather. And when x was equal to a half, that's when we got y was equal to negative 4.5. Now, going back to what this actually means, if we do a quick sketch of a graph, negative x take away 4 would look something like this, and 2x squared minus 5 would look something like this. So it's going to be quadratic, so it's going to be a curve. Now, where those 2 lines cross, it's going to be in 2 locations, and those coordinates are going to be negative 1, negative 3, and a half, and negative 4.5. So again, I can see the relationship between a simultaneous equation where both equations of y equals could also be solved on a graph. So another alternative would be to plot those 2 lines on a graph and see the locations where they cross over. And again, if you're asked to do it on a graph, you can also do the algebra method here as an extra, just to make sure that you've got the correct answers. Just keep in mind that if you have to do it on a graph and you don't do it on the graph, but you have the correct answers from the algebra, you will get 0.
Ouch! This is why in some videos I have unexplained scratches.